Right. Here with Joe Petrelli.
Well, I'm really glad I'm here.
What was it that you wanted to get from the conference, and what is it like the key message that you want to send to people? Derek Evans from AFBI, Agro Food and Biosciences Institute.
Hi everyone, I'm Celine Hanzen and I'm going to go over some eel research that we've been conducting in KwaZulu-Natal, South Africa over the past few years. So in this presentation, I will focus on the Western Indian Ocean region, which means we're not going to talk about European eels that are actually present in North Africa, but we'll talk about what we call tropical eels, which are present all along the Western Indian Ocean region. So anywhere between Cape Town to up to Somalia. Like other ungulate species, our African eel will undertake facultative migration between the sea and our rivers. And the current consensus is that they'd be breeding somewhere off Madagascar and the Mascarene Plateau, which is an oceanic plateau between approximately the Seychelles all the way to Mauritius. So that's about, I think, about 2,000 kilometers long. So for an eel that lives in KwaZulu-Natal, which is the region we're going to talk about in this presentation, it is about 6,000 to 10,000 kilometer migration one way. So let's look at species distribution in South Africa. So we do have 4 species and they're all at the limits of the distribution. Some are actually not present in all of South Africa, and only the province of KwaZulu-Natal holds the 4 African species. So that's the region in red in the east coast of South Africa. KwaZulu-Natal is where I used to be based and where I did my PhD and a couple more years of postdoc research after that. Unfortunately, 3 of our 4 species have been described as near threatened by the IUCN and Anguilla mosambica, which is endemic to Africa. Its status has been revised in about 2019, I think, and some of our data were used to help with the assessment. So we'll go over that in this presentation. So why KwaZulu-Natal? Well, we do have a high diversity of landscape, a high diversity of aquatic life, but also sadly a high diversity of stresses. If you've been following the news, you've seen that Durban and the entire region is experiencing extreme event at the moment, and it's been quite disastrous. So as we said in good times, KZN does it all, believe it. So we've been working towards closing the gap in our knowledge regarding your ecology. First, we'll go over the decline in distribution. Then we'll look into the spatial ecology, the genetics, and then I'll finish with some current project we're working on, and it's about the fisheries and migratory ecology in the Western Indian Ocean. So not just in South Africa, but in different countries as well. So as you can see from the photos, we do use a lot of different techniques to catch our eels, because as I just said, we do have a high diversity of landscape and they use all habitat available in the country. So we looked at distribution across time in KwaZulu-Natal, and I'm going to show you the result for Anguilla mosambica, which is supposedly the most abundant species. For the species, because it's supposed to be so abundant, we do have really good historical and temporal data. So this is KwaZulu-Natal, and to give you an idea, it's about a little bit less than half the size of Great Britain. So it's quite a large area. And here in pink, we have mapped the distribution of Anguilla mosambica based on all data collected from the end of the 19th century. So basically, this is how the distribution should look like in an ideal world, right? So if we go 30 years from now, we see a shrinking of the range. So basically, region that you see in red is probably lost to them. And as you can see, it's usually at the top of catchments. If we look at the distribution in the last 5 years, well, it's more from 2015 to 2021, 2020. This is actually when we started to monitor cases in the river seasonally and really look for them, because it hadn't been done before. So we see an even more dramatic decline in the range. So you know, if we think our method were proper and suitable, it means that everything you see in orange or pink is actually lost. So that's habitat where you don't find them anymore. So we did this exercise for all of the species in KZN. So if you put all of them together and look at the area of occurrence, we first see that the species always had quite different distribution in terms of area occupied, which makes sense because species like Anguilla bicolor, for instance, they kind of like swamp, coastal swamp, and really like low altitude area. And Anguilla marmorata, they grow really quite big. They don't really want to go climb things and waterfalls, so they don't really go far inland in any case. Here we show the difference in area of occurrence at different time frames. And that's where we see that if we compare the last 5 years to the entire data set, we observe decline of approximately 80% for Anguilla bengalensis, which is quite crazy, and even 50% for Anguilla mosambica, which I remind you is endemic to Africa. So these results have been used by the IUCN among other data sets when they did the assessment for Anguilla mosambica to move it from least concern to near threatened. So to get better insight on their spatial ecology, we looked at finer scale and we used radio telemetry to learn more about their home range and seasonal activities. And the idea was that that could help us sample better for them. Maybe we were not looking at the right time or the right spot for them. So what we did was we did track 19 eels over about a year. It was a pilot study. So, you know, we started and we didn't know if any of this was going to work in African environment. So we took 3 species, including Mosambica, bengalensis, and marmorata. And first, we calculated their home range and core area using, it's called the PHRE method. It's been developed actually for otters by Norton and Tarjan. I won't get into the details. I can send you the paper if you're interested, but it's a technique that's partially suited for animals that have restricted habitats, such as a river. So depending on your computing power, you can have really, really good resolution of your study area and really get into fine details. So these are basically home range maps for 2 of our individual. And yeah, so basically there's a little square missing there, but the idea is to show you that they have very, very different behavior, basically. There you go, there's the square. So basically the square here represents the same area. And these are 2 different eels from the same species. So we found that there was a really high individual variability in home range and core area. So that's 90 and 50% use, from about the size of a football field to the size of the Vatican. So it was a pilot study, right? With little individual sample. When we started at, didn't think we were even going to catch 19 eels. So we did it anyway, and we found a relationship between body mass and home range for Anguilla bengalensis, which means that a big eel would then use more space. We also looked at traditional home range, which is the distance between the most upstream and most downstream location, and we can see that some individual used up to 2 kilometer river lengths, but they're not necessarily the one with the biggest home range that we calculated with that fancy new method, because that method considered 90% home range and 50% core home range. So some individual could take sometime a little trip out of their normal home range, which is something that we miss using traditional methods. What I was interested in actually was really to look into seasonality. And we showed that eels would have a really small home range in winter for all species, and maybe showing some sort of winter dormancy. So you would find some tank eel under the same rock for weeks at a time during winter condition. So to give you the idea of, so this is the Tugela River, temperature range from 5 degrees in the winter. That's pretty much European if you ask me, and all the way to 29, 30 degree in summer. So these are quite wide range in terms of temperature. So we also show that all our tagged eels were sharing great portion of their habitat at both intra and interspecific levels. We saw that they were also using all meso habitat available, whether it be very shallow and fast or deep and slow. We also showed difference in preference with season and between species. This is suggesting fine scale, spatial and temporal niche partitioning. So that's about all we learned from radio tracking, although I forgot to mention that we also looked at, we had a lot of recapture and they were healing perfectly well and very quickly, which was very good. But then we also looked at genetics, and which is another simple yet important thing we did. And it was to look at the use of barcoding for species identification. Because I don't know if you realize it, but identifying African eel on the field is a nightmare. It's very difficult, and you have to rely on fin measurement and palette pattern. Relying on fin measurement on eels is quite difficult because, you know, they're quite slippery, and it's difficult to really be precise, I find. So we did show that CO1 barcoding works for our species. So now the next step would be to compare whether the character we use to ID them match their genetic ID or not. And that's something I'm busy with at the moment. We're also exploring the use of eDNA for fish studies in the region. It's still an ongoing work, and Mahlatse, who's smiling on the photos, is the one busy with that. So we eagerly waiting on results to see if it works or not. So far, what have we learned from these two studies? So there's a worrying decline in species range in KwaZulu-Natal. And I don't think it's naive to think that we might lose some of our less abundant and widespread species in the not so far future. Because of their habitat use, flow management needs to be sensitive all year round to allow diversity of habitat. But on the other hand, if you maintain good habitat, it's great. But it can be a bit pointless if they actually cannot reach them, meaning that maintaining habitat connectivity should be a priority. Unfortunately, this is not really on the South African priorities list, being a water-stressed country, and things are not going to get any better with the current situation and the threat of climate change in the region. The good news for eels actually is that all these findings are allowing us to design better ways to sample and to monitor their well-being. For instance, we should probably avoid winter and sample for consecutive days instead of rapid assessment should probably be a better way to do it. And then I think all of this also brought more question. And I think that's something that's very important to look at in South Africa is the importance of river connectivity on coastal habitats. And for instance, in the Tugela, which is the second biggest catchment in the country where I focus most of my work, we have a marine protected area, and that marine protected area rely heavily on the flow from the river. So having impairment of river connectivity in rivers could have quite a devastating impact at sea, but I mean, I don't know, we need to look at it. And then impact on eel recruitment, that's also something we don't know or don't understand yet, because we haven't done really eel recruitment in Africa, except on the Isles. So that's something we're also looking at the moment, but I feel like the more we work on these species, the more question we have. So at the moment, we are busy with a big project involving 4 institutions, and I think about 12 students. They're spread across South Africa, Mozambique, and Kenya. which is great because when I moved to South Africa to, look at eels, I was basically a team of one plus my supervisor, and now we're quite a big team, and I think we're getting people excited about it, and I think that's a win for me. So at the moment, we are looking at glass eel recruitment, silver eel escapement, and fisheries. And in South Africa, we've been monitoring glass eel in the Tugela River, which is the second largest catchment in the country. Here on the graph is actually our first year. It didn't really go well. We only caught 17 eel over a period of a year. And what was surprising is that we actually caught 2 over our winter month. This is a very, very cold season for us. This was in the estuary, about 300 meters away from the actual mouth. So we ran into major issues. It was not safe to work there. We had net stolen, we had net emptied, and it was also a very highly dynamic area. So we kept at it for a year, and then last year we actually moved the nets about 15 kilometers upstream, and now we're actually catching hundreds of them over a few nights. However, we've been experiencing a very, very, very wet summer, and we haven't been able to go sample since I think October or November. So this is very a very much difficult period for us at the moment. All right. Okay, so in conclusion, we do have an uncertain future for our freshwater eels in South Africa. So to give you an idea, this is a map of all the legal dams in the country, well, in the continent, and this is not including the ones that are actually not legal. So yeah, this is not a bright future for Africa, but what else can be done? You tell me. This is I haven't updated with the latest disastrous news, but this is the news we deal on a daily basis in KwaZulu-Natal. So we do have a lot of issues with quality and quantity, big issues with management as well. And also, this is Africa, and it's not always safe to be an eel or an eel researcher in the region. So thank you very much for listening. I thought I'd show you some of our happy faces because we can't be there. Yeah, so thank you, and I'll take any question, I think. Thank you.